Hello dear viewers, this is Gary, the AI voice, speaking to you as Buddy from Town's narrator. I hope you are all in good spirits. So far, the Buddy from Town Space Exploration YouTube channel has covered some of the key stages, but not all stages, of the Big Bang, for the very early universe, and also early universe. Buddy is now ready to explore the Dark Era Epoch and the Reionization Epoch. For its first 370,000 years, the universe was filled with a hot, dense fog of ionized gas. As the universe cooled and expanded, electrons and protons were able to combine to form the first neutral atoms. When this happened, thermal energy from the Big Bang was able to travel freely throughout the universe. This process of particles pairing up is called recombination, and it occurred approximately 240,000 to 300,000 years after the Big Bang. The universe went from being opaque to transparent at this point. Light had formerly been stopped from traveling freely because it would frequently scatter off the free electrons. Now that the free electrons were bound to protons, light was no longer being impeded. The era of recombination is the earliest point in our cosmic history to which we can look back with any form of light. This high-energy radiation has, over cosmic time, cooled and been red-shifted by a factor of more than 1,000, due to the expansion of the universe. This is what we see as the cosmic microwave background today, with satellites like the Cosmic Microwave Background Explorer, and the Wilkinson Microwave Anisotropy Probe. After the CMB became imprinted on the universe, the cosmos became opaque at shorter wavelengths due to the absorbing effects of atomic hydrogen. This began a long period known as the Dark Ages, so called because of the absence of stars, and the extremely dense intervening neutral hydrogen gas. The period began around 370,000 years to about 1 billion years after the Big Bang. After recombination and decoupling, the universe was transparent and had cooled enough to allow light to travel long distances. But there were no light-producing structures such as stars and galaxies. In other words, long ago, before the first star sparked to life, the entire universe was a sea of darkness. The Dark Age of the universe marked the last time when empty space really was empty, no planets, no suns, no galaxies, no life. Just a fog of hydrogen atoms forged by the Big Bang, and left to slosh through the darkness. This is the period after the formation of the first atoms, and before the first stars. Although photons exist, the universe at this time is literally dark, with no stars having formed to give off light. With only very diffuse matter remaining, activity in the universe had dramatically curtailed, with very low energy levels, and very large time scales. Little happens during this period, and most of the matter in the cosmos at this stage was dark matter, with the scant remaining ordinary matter, comprised largely of neutral hydrogen and helium. This period, before the first stars were born, is thought to have lasted several hundred million years in our 13.8 billion-year-old universe. During the Dark Ages, the temperature of the universe cooled from some 4,000 K to about 60 K, or 3,727 degrees Celsius, to about -213 degrees Celsius. Only two sources of photons existed. The photons released during recombination decoupling, as neutral hydrogen atoms formed, which we can still detect today as the cosmic microwave background, as well as the photons occasionally released by neutral hydrogen atoms, known as the 21 cm spin line of neutral hydrogen. The hydrogen spin line is in the microwave range of frequencies, and within 3 million years, the CMB photons had red-shifted out of visible light to infrared. From that time until the first stars, there were no visible light photons. Other than perhaps some rare statistical anomalies, the universe was truly dark. Next is the Reionization Epoch. In the fields of Big Bang theory and cosmology, Reionization is the process that caused matter in the universe to reionize after the lapse of the Dark Ages. In the early universe, cosmic reionization involves the coupling of nonlinear physics of galaxy formation, with the nonlocal physics of gravity and radiation transport, to produce a global phase transition. The emergence of these first stars marks the end of the Dark Ages in cosmic history, a period characterized by the absence of discrete sources of light. Understanding these first sources is critical, since they greatly influence the formation of later objects, such as galaxies. The first sources of light act as seeds for the later formation of larger objects. From this point on, most of the universe goes from being neutral, back to being composed of ionized plasma. Some of the first structures to form are thought to have been quasars, actively accreting supermassive black holes. The first quasars form from gravitational collapse, and the intense radiation they emit reionizes the surrounding universe, marking the second of two major phase changes of hydrogen gas in the universe, with the first being the recombination period. Other structure formation included massive galaxies and the first generation of stars, called the population 3 stars. The population 3 stars formed within a few 100 million years after the Big Bang. These stars were the first source of visible light in the universe after recombination. The intense radiation from incipient quasars and stars started to ionize the neutral hydrogen in their surroundings, bringing in the second milestone of the universe, known as the Epoch of Reionization, or EOR. The Epoch of Reionization refers to the point when most of the neutral hydrogen was reionized by the increasing radiation from the first massive stars. As the first stars, dwarf galaxies, and quasars gradually form, the intense radiation they emit reionizes much of the surrounding universe, splitting the neutral hydrogen atoms back into a plasma of free electrons and protons, for the first time since recombination and decoupling. Theory predicts that the first stars were 30 to 300 times as massive as our Sun, and millions of times as bright, burning for only a few million years before exploding as supernovae. As the first stars switched on, their ultraviolet energy began to reionize the cosmos, punching ever larger holes in their hazy surroundings. Eventually, the effect of these young, massive stars, and their infant galaxies, enabled light to shine freely through space. The energetic ultraviolet light from these first stars was capable of splitting hydrogen atoms back into electrons and protons, or ionizing them. Reionization is an important phenomenon in our universe's history, as it presents one of the few means by which we can, indirectly, study these earliest stars. But scientists do not know exactly when the first stars formed, and when this reionization process started to occur. Additionally, the first stars that exploded as supernovae might have collapsed further to form black holes. The black holes started to swallow gas and other stars to become objects known as mini-quasars, which grew and merged to become the huge black holes, now found at the centers of nearly all massive galaxies. Over time, areas of higher gas density began to collapse under gravity, and the neutral matter in the universe began to clump together. Eventually, these regions cooled and collapsed, igniting nuclear fusion in their cores, and leading to the first stars and galaxies. As the first stars emerged, their energy heated the surrounding medium, once again ionizing the hydrogen in the universe. At first, these areas were like small bubbles of ionized gas surrounding bright energy sources. That is because the newly born stars and galaxies ionized ever-expanding bubbles around them, allowing light to finally travel unimpeded again. As these bubbles grew and punched ever larger holes into the neutral universe, they eventually began to overlap, enabling ionizing radiation to travel farther and farther through space. Once the majority of the universe was reionized, approximately 1 billion years after the Big Bang, light across much of the electromagnetic spectrum could travel unimpeded through the cosmos, eventually revealing the universe as we see it today. Despite being reionized, the universe remained largely transparent during reionization. As the universe continued to cool and expand, reionization gradually ended. This concludes Buddy's video on the stages of the Big Bang, Dark Ages Epoch and the Rhinization Epoch. If you would like to follow along to see Buddy from Town become Buddy of Singularity, please click subscribe, and a like would be appreciated. Until next time, dear viewers, keep looking up and looking back, way back.